Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the two double bonds in the molecule. Double bond 1, the exocyclic alkene on the left side of the cyclopentane ring. Its two carbons bear, left carbon has NC, cyano, and CH2NH2, aminomethyl, right carbon has the cyclopentane ring carbon and CN, cyano. Double bond 2, the exocyclic alkene on the right side of the cyclopentane ring. Its two carbons bear, one carbon, EXO, has CU and CH2O, the other carbon is part of the cyclopentane ring. Moving on to the next step. Assign priorities for double bond 1. Left carbon substituents, NC, cyano, CN, attached via C, versus CH2NH2, attached via C. For NC, the nitrile carbon is triple bonded to N, so phantom atoms give C, N, N, N. For CH2NH2, the carbon is bonded to N, H, H, comparing C, N, 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 C, N, H, H, so NCCH2NH2. Therefore, NC has higher priority, 1, and CH2NH2 has lower priority, 2, on the left carbon. Right carbon substituents, CN, cyano attached via C, same reasoning as above, C, N, N, N versus cyclopentane ring carbon, C bonded to C, C, H. Comparing C, N, N, N versus C, 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 H, N, C, so CN cyclopentyl ring. Therefore, CN has higher priority, 1, and ring carbon has lower priority, 2, on the right carbon. Configuration, NC, priority 1, left, is on the same side as CN, priority 1, right, both are on the same face of the double bond as drawn, NC upper left, CN lower right are on opposite sides. Looking at the structure, NC is on the top left and CN is on the bottom right, they are on opposite sides. Therefore, the two higher priority groups are on opposite sides E configuration. Moving on to the next step. Assign priorities for double bond 2. EXO carbon substituents, CU, C bonded to O, O, H by phantom atom expansion, C, O, 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 versus CH2O, C bonded to O, H, H, C, O, H, H. CU CH2O. Higher priority is equal to CU top. Ring carbon substituents, the two ring carbons, the two CH2 groups of cyclopentane connecting back. Both sides of the ring from this carbon lead back through CH2 chains. One path leads to the other exocyclic double bond carbon, which bears CN and aminomethyl via the other alkene. The substituent going toward the other double bond bearing carbon has higher substitution. The ring carbon has two ring, CH2 paths, one leads to C bearing to CN groups and aminomethyl, higher priority, the other leads to a plain CH2. Higher priority is equal to the ring path leading toward the more substituted carbon. The CU group, higher priority on the EXO carbon, and the higher priority ring substituent by analysis of the drawing, CU is on top and the higher priority ring path is also on the same side, they are on opposite sides of the double bond E configuration. And for the final step. Both double bonds are E options, A, E. Only one double bond described, B, Z, C, E, E, D, Z, Z. Since both double bonds are E, the answer is E, E. Why other options fail? A, E describes only one double bond, incomplete. B, Z, incorrect, priorities place higher groups on opposite sides for both bonds. D, Z, Z, incorrect assignment of configurations. Therefore, the correct answer is C. Therefore, the correct answer is option C.